Okay. All right. So from last class, we actually had a challenge, and it was a simple challenge that we had. But then I actually believe it was from my end. Should I say from my end? It was from my end, but not. I actually cannot really explain what really happened. I think we actually talked about running this command to start up the instance. We talked about ECTL, EKSCTL to create cluster, and which was what I did. So during my troubleshooting, I just got to realize what really happened. Let me see if I'll still have it here. I got to realize what really happened. So when you run EKCTL command, if I've mentioned this CloudFormation proprietary language, this CloudFormation here is an Amazon language, okay, that Amazon used for setting up infrastructure, just like you have your programming language. So CloudFormation is like Amazon markup language for configuring infrastructure, spinning up infrastructures, and also that's CloudFormation. So when you run this EKCTL commands, there's, I believe, this to just set up the CloudFormation and run it. So now, when you put CloudFormation in your AWS, so this is the dashboard for CloudFormation, okay? So you have stack sets. So now we have like 3 stacks that I already run. So this is one stack, EKCTL DevOps. This is Node Group, which was run on, okay, November 14th. So this was the first stack that I actually created. Let me open it. So I'm just trying to show you how I actually troubleshoot to get the issue. So once I opened that, then I went to events. Then I realized some events were still in progress. So then why were these events still in progress where you have some others in create complete? You can see create complete, but you have this one create in progress, you know? So then why do we have that? Which just inspired me to just try to spin up another EKCTL command. So I had to issue another EKCTL command. This is actually the resource that we actually spin up. So that's for the first one. Then I had to run another EKCTL command. Let's go and see the difference. So this is the new one that I think I run. And then I went to events and I think everything completed. Oh, create in progress. Wow. We still have create in progress, but I went straight to my dashboard. Then okay, you can definitely see for yourself, like we still have create in progress. Where is it? We still have create in progress. This is policy, ELP permissions, route table, control plane. Why do we have all this route table? Just these are all the components that are actually configured when you are spinning up a Kubernetes, NAT gateway, ingress internode, control plane. So then go to your Kubernetes cluster. This is the Kubernetes cluster. I just went straight to my Kubernetes cluster and then I took a look at it and went to my compute. And I was able to see my node group. Unlike the ones we had before, like there was no node group. This is the desired size. These are all the information we need. And then went to my command terminal. Sudo su. This is my command line. And then I told you kubectl gets nodes. And then we have the 2 nodes running. If you remember from last class, we did not have these nodes running. All we got was no resource found. So that was how I was able to get over that. Okay. Please, do you get me? Are you following?
Yes.
Okay, fine. So in the last class, you actually know what the issue was. The issue was when we checked the events, it was complaining that there was no nodes. And then I had to figure out why there was no nodes, and that was what I did. I spin up another instance. So I don't know why the first one has no node. I really didn't have explanation for. Then after issuing the second command, then we got our node. Okay, so let's continue with where we stopped before that really happened. We have waiting room, admit all. Okay. All right. So I told us about this Kubernetes interactive tutorial. Sorry, I'm with you. Just trying to close some of these tabs that I felt I will not be needing. Going to see clear automation. All right, so I told you about the Kubernetes interactive class, which I think I shared on the group. So I don't know if you have time to practice. If you've not had the time, you can also check it out, where you have your CLI to be able to do a lot of things in Kubernetes. So in case you don't want to use this instance, or if it's giving you issues, or you don't want to spend money, this is a good platform for you to practice. It's not just convenient for me to train from here. That's why I don't really want to consider that. It's going to be too stressful, but for practice sake, it's a very good one. The same thing, kubectl gets nodes. You can run your kubectl gets nodes. Okay, so now, while this, you have to spin up your Minikube. We did this from the last class. Then start Minikube. It's going to take some time to start the Minikube. So while it's doing that, let's go to the next one. So it's still starting the Minikube. Like, this is how I know it's starting anyway. You can see this. Once it's done, it should be able to return us to this terminal. Okay, so it's enabling the add-on. So default storage class, we have storage class, you have provisional. There are some of the Kubernetes objects too. Okay, but we'll not be dealing with that. It's not in the scope here anyway. So now kubectl is now configured to use Minikube. Okay, so now kubectl gets nodes. Let me see. All right, so now we have the nodes running, and then you can always issue all the commands you can have on Kubernetes, the resource found. So you can also deploy resources, and this is it. You have everything running. So in case you don't want to use EKS because it's going to consume money, you can also use this playground. You can deploy, you can do a lot of things. Just follow this tutorial for you to get familiarized with it, and it's a very good platform. Okay, so let's continue. Now, the first thing I wanted us to do is, okay, from the last class, I'll try to upload the video. I explained a lot of terms to us. I explained pod, deployment service, daemon sets, all this. Then I explained some of the, what's this node deployment? The commands you can issue, yeah, the command you can issue, okay? So you can issue kubectl get with all this to see what's happening. And then these are some of the troubleshooting commands. So kubectl get is to list all the pods or all the objects that you have running. So you can just say kubectl get nodes, kubectl get deployment, kubectl get pods, kubectl get ingress. In case you've forgotten, I will try to upload the video. You can check it out. So I explain all this step by step. Then that's for get. So you can also describe. So for describing, you can describe a particular pod. Okay. So let me show us how this works with one of these. Do we have any pod running? Okay. So let's say I want to describe this pod. You can just say kubectl describe. then the pod name, then the pod name. Copy. Let me copy this. Copy. kubectl describe. Okay. Describe is just to give you a detail anyway. In case you're still confused, don't worry. You get to understand very soon. And kube-system. Doesn't have a resource type. Oh, kubectl describe doesn't have, okay. So I have to specify the pod. Sorry. So kubectl describe the object type, which is a pod. All right. So now this is why it's describing. This is why I said I don't really like this for training. I will have to maximize so that you can see it very well in a single line. So this is me just trying to describe the pod. So it's going to give you all the details about the pod. I just try to describe the pod now. This is kubectl giving me information about its Minikube, start time, you know, everything you need to know. That's how describe work. Then logs. You can also see the logs of a pod. Let me issue logs for this pod so that you can see. So instead of describe, just change describe to logs. Pod not found. Oh, now if you're using logs, you can only do logs on a pod. So you remove the object type, which is pod. So you don't have to specify pod. All right. So this is the logs inside the pod. So I'm just trying to explain the troubleshooting tool that you might need. So these are the logs of the pod, Minikube storage provisioner. You know what logs means. Log is just keeping record of what is really happening. Like, let's assume I have a pod to deploy an application that can sign up user. So as you're assessing the application, is going to be logging your events, everything you're doing. That's logs. So this is how to actually check for the logs. So these are the events actually happening inside the logs. Okay, so it's just like a means for troubleshooting. And then what other one? Events. So you can, okay, now let me try to put this. So you use get on objects, on all objects, Kubernetes objects. Okay, Kubernetes objects, then describe. You can describe Kubernetes objects too. So you use describe on Kubernetes objects. Okay, so then logs, you can get the logs of a pod. Okay, then events. So you can get events inside the namespace. So now, what is a namespace? In case you are confused, what is a namespace? Namespace is a way of isolating environments. Okay, so let's assume you need different application with the same name running inside your cluster. Okay, so you don't want to, if you use the same name, it's going to complain. Like, it's just a way for you just isolating, just like you're using your Docker to isolate the application. Are you getting it? The same way namespace. So a namespace is a way for isolating workloads, Kubernetes workloads. Okay, so now let me say kubectl get namespace. Let me get namespace now. So you're going to see these are default namespace that Kubernetes creates. So you can also create your own namespace. So I can say kubectl create namespace. Then what's the name of the namespace? Let's call it DevOps. Okay, so if I get my namespace now, you see it. So I can deploy application to this particular namespace. Are you getting it now? So now, if I issue a command like kubectl get pods, Now, okay, we have this pods running. I think it was the one actually deployed. I have to delete it. So now these are default pods. So once you issue kubectl get pods, all it does is it actually gets the pods in that particular namespace, in a default namespace. All these things are going to be making sense in case you are still, you probably are still struggling with some of the things I'm saying, but definitely it's going to make sense by the time we start issuing some commands. Okay, I'm just trying to explain these things so it will not be strange, but it's going to make more sense to you very soon. So now when you issue kubectl get pods, all it does is it actually look for pods in this particular namespace called default. And again, I can now issue like, okay, get pods in a particular namespace called DevOps. Now, I just created this DevOps namespace. We are not going to get anything. You see, no resource found in DevOps namespace. I'm trying to do this. Okay, so now we can see no resource found in DevOps namespace. Why? Because I've not really deployed anything. So I can definitely deploy into I will definitely deploy into this DevOps namespace and you see it. And another thing you can also do is you can say get pods in all namespace. You just say all namespace. That's the shortcut, but this is the complete command, all namespaces. All namespaces. So it's going to show all the pods that is in namespaces. So all these pods that you see that is running, they are the pods that actually EKS deployed by default that you actually need. So now look at this. We have AWS node, okay? You have the core DNS, and then you have the proxy. These are the default pods that are running, that AWS actually creates to configure your EKS, okay? So that's why you have them in kube system, okay? So that's that. Then I think another thing you can also do, okay? Before we go into the other thing, let's try to issue our first command now. Let's try to make this deployment now. This deployment has been done to default. Let's see what we're going to have. This is the command. I told you if you want to issue any kubectl command, the format is kubectl action, then what's it called? The resource you want to deal with, the resource, and then options. Okay, so now that's how it actually works. So now look at this command. I said kubectl create deployment. Okay, so this is the main command, kubectl create deployment. Then the next one is, what is the name of the deployment? We are naming the deployment Kubernetes Bootcamp. And then we are passing the image. We told you Kubernetes is an orchestration, container orchestration tool. That is, it works, it's underlining, what's it called now? Component is Docker, okay? So now you have to specify the image, which is the image is gotten from gcr.io /Google sample/Kubernetes, just like you have your docker.io, like, we actually created a Docker image and then we pushed to Docker Hub. So instead of using Docker Hub, they are using gcr.io. That's where the registry is living, okay? So let's deploy. Fail to create, look at it, it says it already exists, okay? So that's for default. In this case now, if you not specify a namespace, it's going to install it in default namespace. Now let's run another one, but in this case now, let's deploy it to DevOps. All right, so you can see created, and let's do kubectl get pods and space DevOps. All right, so now look at it, we have it running. So on this particular image now, this is pods, okay, sorry. If you look at this now, what we actually did was we actually created the deployment. So I told you deployment is actually for managing pods, Okay, so it's like higher, how should I say it now? It's an advanced version of a pod. Okay, so inside a deployment, you have your pods. Okay, so you use your deployment to actually manage pod. Now, instead of getting pods, now let's get deployments. Instead of getting pods, let's get deployment. So you see, deploy. You can use deploy, you can use deployment. Okay, so now this is the deployment. As you can see, look at the name. Is the name that we actually named here. Okay, okay, yeah, namespace deploy, yeah, fine. This is the name you actually use. You can see bootcamp, Kubernetes bootcamp, which is what we have here. Okay, and then take note, look at this pod now. It's actually following the same format, but this is how you know it's a pod. After that, it's going to add some, some alphanumeric characters, which is what you have here. That's to show it's a pod, but then you can know like it belongs to a particular object, okay, which is deployment. You can see it here. All right. So now you have your deployment. Then another thing you actually want to do. Let's try to describe this particular pod. Let's try to describe this particular pod. Oh, sorry, please. Am I too fast? I hope I'm not too fast. Hello, can anyone hear me?
Yes.
Yes, definitely we can hear you.
Are you following me?
Yes.
All right, thank you. So now let's try to deploy. Let's try to describe this pod to see what we have. So for you to describe a pod, you just copy the pod. Okay, so kubectl describe, then you do pod. Okay, you want to describe a pod and space, then paste, then which namespace. If I don't put namespace, it's not going to find, it's going to tell me no resource because it's running inside DevOps namespace. If I not put namespace, it's going to be looking for this particular port with this name inside default and it's not existing. So I have to put DevOps and then issue. All right, so this is just giving me more insights into that particular pod. Okay, so now it's telling me inside the node it's running, it's telling me the label, You can actually search pod by label, it's giving me the annotation, the status, the IP, you have the IPs, then controlled by replica sets, okay. Container ID, this is the image you actually specified, okay. So it said no pods, no host pods running. It's in the running state. So this is just to give you more insight into what's really happening. Okay, so if you want to understand what is really happening inside the pod, just do that and just check and you get loads of information. Okay, so now look at this now. At the end, you can see events. So it's also telling you the event that is happening inside the pod. Then look at it now, normal. It said pulled image, container. Look at the step. The first thing, it's actually pulled image. You can see the schedule pulled image. Then it said it's created container. Then started container. So these are the set of events that actually happen. And another thing again, you can also do logs on the particular pod. I said when you are doing logs, you don't have to specify because you can only do logs on a pod. So you don't have to specify the particular objects. Oh, logs. All right, so look at the log. You said Kubernetes started on blah, 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 blah. So that's it about log. So now, one thing I now notice is one thing that happens about Kubernetes pods is every pod actually has an IP assigned to them. Okay, so now if I should do something now, if I should restart this particular pod, if I should actually delete this particular pod, Let me try that. It's going to create another pod with a different IP. Now, then how do you configure that with your application or with your load balancer or with your DNS, because the IP is changing? Okay, so that is what we now have another Kubernetes object that actually helps in handling that, which is actually called Kubernetes service. They call it Kubernetes service. Kubernetes service is another Kubernetes object that is used for exposing the pod, the running pod, okay? Maybe to the internet, to the world, to the cluster. You can use it to monitor things, you know, that's to configure how your application is reached and all. So that's Kubernetes service, okay? Now, another thing about pod is pod is not by default, it's not accessible. You cannot access pod. So the next thing we'll be doing now is we need to expose this pod. So now what I'm just doing is I'm just doing all these configurations interactively, but definitely that's not the way to go. We'll be using a YAML file very soon, which is what we have here, but I'm just trying to give you a quick one here. I don't really do this anyway. Like, this is not how I make my deployments. You know, this thing, Kubernetes is a little bit difficult right now at the beginning, but then I'm going to take it to a level like, just follow me. I'm going to take it to a level like Kubernetes will be so simple. That's where we are going to. They've made our life in Kubernetes very easy. It's just this beginning that might look like that, but just keep following me. So now the next thing I want to do is I want to expose that particular pod. Okay. So now this is the command, kubectl expose. I'm exposing this deployment, okay, which is called bootcamp. Then I'm specifying type, node ports, then which ports, 8080. So now let me explain this type to you. Let me explain what this actually means. So when you're working with service, you have three types of service, or four. Okay, the first one is cluster IP. The second one is node ports. The third one is load balancer. And then the fourth one is external name. Now, cluster IP, just like the name actually implies, it actually means you're configuring your cluster for cluster IP. That is, the IP is going to be generating, that is going to be exposing, can only be reachable inside from within. It can only be accessible only from within the cluster. It cannot expose it to the outside world. That's cluster IP. Then okay, within cluster. Then what is node ports? You know, your Kubernetes, I told you, with node ports, kubectl gets nodes. So now what this is actually telling you is these nodes that you're seeing, that is running inside your cluster, you can access them on, you can access your application. It's exposing your application through those node ports. Okay, so that is, how do we get the node IP so that we can know the ports? Okay, now for us to get the node IP, you can do wide. To get more details, you can do wide. So it's going to show this is the IP of each node. If I go to my Kubernetes EKS dashboard, you should be able to see that. Okay, where are the nodes? To be honest, these guys are annoying. I have to be honest. AWS is actually annoying. So now, when you look at it, this is DevOps. This is one of the nodes. When you look at it, 43206. So this is it. Okay. So what it's actually telling us is we can expose an application that you can access an application through a node port, that is this port, this IP, then the port which you are specifying, which you want to expose on. Okay, so that's node ports. So through running nodes, through cluster nodes. Then the third one is you can access the application through load balancer. Okay, so this load balancer are provided by your service provider. Okay, so if you are on EW or you are on AWS now, if you use load balancer now, definitely it's going to provide you a load balancer IP. Okay, so that's load balancer. Then the third one is external name, just like you actually specify your DNS. So you can use your DNS name. So by the time you specify your DNS name, it's going to route the DNS name to your application. So those are 4 different types that we have. But for now, we are not going to be using load balancer. Let's work with node ports. Okay. Okay. The first one I actually told you is the first one you can do is through your cluster IP. That is, inside your cluster, you can go inside the node and you can reach an application through the cluster IP. Let's see how that works anyway. All right, so now let's go back to this. Now for this let's try to deploy this using, let's expose the application. Let's deploy a service using node ports. Okay, so let's deploy this using node ports and see what we have. Let's deploy this using node ports. Okay, so it's telling me I already deployed it, but then let me deploy it to DevOps namespace anyway. I'm going to be putting it on DevOps namespace. It might be conflict. Let me put 8081. Would there be conflict? It will really matter. Make port 8081. All right, so now I've deployed the new service now to DevOps namespace. So I told you when you use expose, it's like you're creating a service. Now let's check service, kubectl get services. So when you do kubectl get service in DevOps namespace, so now you can see created 23 seconds ago. So sorry, I think I did the wrong thing. I think I did the wrong thing. This is expose service. I actually want to delete this service anyway. So I want to delete this service. Do that. And DevOps. I exposed the wrong port. So SVC, the shortcut for services SVC. Oh, just what am I doing? Delete service. kubectl delete. So I told you kubectl delete, then action. I'm trying to delete a service. Then what's the name of the service? Bootcamp, which is what we have here. Bootcamp, Kubernetes Bootcamp, which namespace in DevOps namespace. Enter. All right, so deleted now. Let's see, get service. kubectl get service. So now it's empty. Let me redeploy. So in DevOps, I'm deploying to DevOps namespace. And then let me get the service now and see. So we have the service running. So look at it, type running as a node port. And when you look at this now, you see it's actually assigned cluster IP by default. Okay, so this is actually telling me I can access this application from another pod that is living inside this cluster. That is what this actually means, using this IP. Are you getting it now? Then external IP means I can't actually access it from outside. Okay, you can get this when you deploy as a load balancer. Then which port? So it's exposing this application, which is port 8080. It automatically map it to a port, which is, and then I can actually specify a node port, but in our case, we didn't specify a node port. So it automatically assigns it to a port. There's a range of ports for node ports, I think between maybe 30,000 to 31 something. I'm not really sure, but there's a range of ports that it automatically assigns. So this is the port that I actually choose. And then it actually means I can access the application on these ports using the node IP. Using the node IP that we actually did. This is the node IP. So what it's telling me is I can copy this node IP. Okay, I can copy this node IP and then which ports? Let's do it. So now which ports? It's running on this particular port. Okay, so let's see. All right, we are running. Interesting, right? Hello.
Yes, sir.
Hi.
Well done.
Yeah, I said interesting, right?
Yes.
Yes, so
All
it
right.
wasn't easy.
It wasn't easy, but you know, do you know this thing is so fun to me right now? It's ABC. But before, when I started, all these commands, I have it somewhere. I'll keep it. Okay, I want to check pod. I'll just go and check it. I don't know it offhand. But now I don't really need to get it anywhere. So it's always like this. You can't expect it to just be a part and parcel of you. Just like you are teaching all this speaking 1, 2, 3. Nobody the first day they know 1, 2, 3, but how is 1, 2, 3 to you now? It's almost like a way of life. In fact, it's a way of life to you now. So that's life. That's how it is. But to me right now, these things are fun because this is what I've been doing for a while. So far, so good. All I've been doing is it's offhand. Okay, so I just want you to do it offhand. It's not in a day. I didn't get it in a day. It's because it's what I do on a daily basis. So the first thing you just have to focus now is get your first job and keep practicing. So how can we get to your first job? You have to know these fundamentals, at least be able to talk about it. You may not be able to issue the commands offhand, but be able to talk about it. You're able to know what to do, you know, how to go about things, and also, which is what this class is all about. Let's go on. So other things we could also do is you could also describe the service. Or before we go on, do you have any question? You know, maybe something you really want to really clear in your head that will help you understand better. If you have any question, please feel free to ask. Do you have any question? All right, I will take silence as no question. So another thing you could also do, okay, here now we've actually described a service. Look at the information, it's the namespace, the labels, the annotation, no annotation, the selector, the type, node port, IP family, policy, single stack. This is the IP, cluster IP. This is the ports, then the assigned ports, blah, blah, blah. So another thing you could also do is kube exec. You know, you remember in your Docker, you could do Docker exec, right? You could execute into, like, it's just like you're executing into a container. You could also kube exec into a pod. Okay, so now let's kube exec into a pod. I told you the smallest running instance of a Kubernetes is pod. So if you are dealing mostly, you are dealing with a pod. Let me quickly go over this again so that to brush your knowledge. The smallest instance of a Kubernetes is pod. So with your pod, you can manage deployment with pod. That is, you can specify, okay, I need 2 instances of pod running, 3 instances of pod running, 4 instances of pod running, you know, just for you to configure your load balancer. What is a load balancer? A load balancer is actually a way for spreading a load. Okay, how can I take it for instance now? How can I, like, you're balancing a load, you're spreading a load across different surfaces. Are you getting it? Instead of going through, which analogy can I even use best? Which analogy? I'm trying to see the best analogy that I can use. Trying to see the best analogy I can use, like your load balancing. Okay, take for instance now, you actually have you have a land, okay? You have a land. On that particular land, so people can decide like, oh, I want to build 4-story building, I want to build 5-story building, I want to build 6-story building, and then to be tall. Do you know there are some land that they are not conducive for some type of building? You cannot go and be building skyscraper inside what's it called? A riverine area, you know, that's a swampy area. You get that kind of a thing. So now load balancer is just a way. Why can't you do that? Because the load will be too many and the land is not strong enough to hold it. So instead of you now building skyscraper on a particular land, you can just spread different building on different surface. Are you getting it? So it's like you're spreading load. Instead of overloading a particular thing, you're spreading the load across different surfaces. That's load balancing. So now if you want to load balance, you can say, okay, give me 3 pods because I want to spread loads across all those pods. So you now configure a load balancer to act. The load balancer will be the one that will be automatically be distributing load. Okay, pod A, pod B, pod C. Okay, direct this traffic, just like you used to have your traffic warder. Okay, you go this way, you wait, you know, just distributing. Okay, so that's the concept. So with deployments now, you can actually use to specify, okay, please give me 3 instance, 3 pods running. Okay, so you can say, give me 4 pods. That's what your deployment does. Then service is actually for exposing. Then you have daemon sets. So daemon set is take for instance now, we have 2 nodes running inside the cluster. So let's assume you want to be monitoring the source usage. Okay, or you want to be doing something on a particular pod, on a particular node. So you're telling it like, okay, before you do that, in I think earlier we actually described a pod. Okay, look at this part. You see, we actually describe a pod. When you describe a pod, it's going to tell you on which machine is the pod running. Look at it. It's telling you which node. That is 196.168. You can see it. 196.168. 196.168.1856. 196.168.1856. So you can see it's telling you like this pod is running inside this node. Okay, so now if you're running as a daemon set, you're telling it like, okay, run each pod inside each node. That's what daemon set to do. Like now, what it's going to be doing is like, okay, how many? It's just consider how many nodes is running. Okay, we have 3 nodes, we have 2 nodes running. That is, you're going to see 2 pods running, and each of the pods will be running on each instance. Okay, so that's what daemon set actually helps. It helps you to run a pod, you know, on each instance, on the number of instances. So each instance living inside the cluster is going to have instance of pod running. That's daemon set. Then you also have replica sets. So with replica set, it's just like you're configuring how many replicas that you want running per time. So you can say, okay, 3 replicas of pod, 4 replicas of pod, just like you're configuring in your deployment. That's replica. Then with your secrets is, you know, maybe your confidential details, your username, your password, your private keys, blah, 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 you know, confidential things. That's for secrets. Then your config map. Your config map is your variables, you know, probably maybe you need some variable names, you know, that they are not confidential, that at least anybody can easily see. That's what you use your config map to do. And then your ingress is actually for routing, maybe for routing to DNS, for configuring your TLS, that is your HTTPS, you know, your secure sockets, that's what you use your AWS for. So that's that anyway. Where did I stop before I actually went ahead to do that? kubectl get ports. Okay, before I continue, please, do you have any question? Please, I would like you to ask question. If you have anything you don't actually understand, please just ask so that I can make you understand better. This Kubernetes is very interesting, and it will be interesting where you really understand. It should not be a burden. I don't want it to be a burden. So if you have question, please ask. Okay, I will take that as no question, that you guys are following me. Okay, so then I have this command here, kubectl get ports. kubectl get ports based on service label, which is, I will just omit this later. I'll make you understand. I was talking about replica sets. So now look at this replica set now. Now you can use it you can specify the number of replicas. Let's do something now. Presently, when you do kubectl get ports, oops, because it's idle for a while. All right. So now when you do kubectl get ports, you really have one instance of the pod running, DevOps. Now, let's scale it to any number of replicas now. Let's see. Let me change this to 2. Okay, scaled. Let's get the pod and see. Replicas. Scale deployment. Okay, is it deployment? All right. kubectl scale deployment. Endeavors. Okay, so I didn't specify the namespace. It's supposed to be DevOps, right? I told you if you just specify namespace, it's going to check default. It's going to check the default namespace, right? So you can say, now look at this now. This is the replica, because I actually I scaled it up, to 2 replicas, so you can see. So now we have 2 instances of the pods running. I don't know if you get what I'm saying now. So now, one of the another question you want to ask is why are you running multiple instance, okay, replicas? It actually helps you in doing rolling updates. Probably maybe you want to update, it will just be cleaning the ports one by one, and that's one of the usefulness for rolling updates. Okay, so when you're doing updates, by the time you're still updating this instance, that this one is down, the other one is running, or maybe the process of healing, that's another thing about Kubernetes. It has this self-healing capability, all those things. At least when one pod is faulty, the other one is working and all. So that's one of the usefulness. So now the simple command is just replica. You can upscale the replica. Another thing is, this is another trick for where if you want to restart a pod. There are some scenarios where you need to restart a pod. Another thing you can just do, okay, probably you need to restart a pod because you want to do some updates and all. It's as simple as just change the replica to 0. And then after that, you just change it back to 1, and it's like you're restarting a pod. And just like I told you, every pod you are restarting, the IP is changing. That's why we have our service. Okay. Oh, come on. Please, do you actually understand what I've said, or muddled everything up. In my head now, I feel I'm communicating. I feel like I'm driving somewhere, but I need to get your feedback.
Actually, I'm trying to wrap my head around it. It's a new technology that we are just getting exposed to.
Yeah.
What you are explaining better.
Your voice is breaking. Your voice is breaking.
Hello, can you hear me now?
Okay, yeah, I think it's better now.
Hello.
Yes, it's better now.
Yeah, I said that it's a new field entirely. It's a new thing entirely. So it's kind of vague to some extent. The way you're explaining it, I'm getting it. So I've tried to read it myself. I tried, but it's actually as getting into my head. So, but I'm seeing it now.
Huh? I wish I could get. So you said as I'm explaining, are you getting it better now, at least? Or I'm confusing you the more?
Yes. No, that was what I said. I said I'm getting it better than when I started reading about it. I'm getting it better now.
Yes, that's what this is all about. You know, if I say go and read these things, you may not really get it. And that's why I said, one of my colleagues is actually part of this training. I told her that this is the difference. I'm not doing training. This is not training. I'm actually giving you work experience directly. If I want to train, I can just say, oh, this is Kubernetes, and I'll just run Kubernetes, do this. But no, that's not what I'm doing. I'm trying to, give you the experience of how to bring everything together. Now, if somebody just joined this class and trying to learn Kubernetes, the person might struggle because you didn't really come with us from start. So it's like we are building layers here, which is what I keep on building from time to time. And, hopefully at one stage, we are going to get to a level like you prepare yourself for the interview. I'm telling you, like, we prepare ourselves for the interview, we do the interview together. In fact, I might even run interview for you, and so that you see how these things work and give you some ideas, and that's the level we are going to. So yeah, I'm actually happy to hear that feedback anyway. It's not going to jump on you. You have to do your homework, you have to practice, you have to read ahead. After the class, you still have to practice and do it. At the end, you'll be so happy. I'm telling you. So yeah, I'm happy about the feedback. Please, any other person?
Yeah. Good evening.
Good evening.
Thanks for the effort so far. Yeah, as the person who just finished talking said that we are trying to wrap our head. For me, this will also be the first time I will also be using Kubernetes.
Yeah, that's
and
why
I think there's been a back and forth so far, so to speak. So I think this class has actually opened our mind and to the possibility of really making it easy for us. So you get, because I think probably that was the reason why, due to the back and forth, probably that was the reason why some people didn't really show some interest in the class again. But in as much as we are still moving forward, I think with what you have done so far this evening, I think it's still a good one. And then I'm really, really impressed. I'm also trying to do some self-development for my end, so as to also make the learning process very easy. So
yeah, nice.
I'm grasping it so far. Yeah.
Yeah. To be honest, the back and forth, I try as much as possible to reduce it. It's just like I told you, this thing, it's a trade-off, but people cannot understand. It's not easy on my side.
Yeah.
Why? Because it's not easy on my side. Why is it not easy on my side? I can easily do these things before the class so that there will be no problem. But I wait for the class so that you guys can see these things, so that it's not be like a magic. But some people might not understand. Some people are, oh, it's just wasting my time. I could easily set up the whole environment that you guys will not even see anything. And you not even see the problem. I'll just tell you this, but I really don't want to do it. It's not even going to help your experience, because now when you know all those things, by the time you start doing the job and then you see the problem, you're like, this is it's part of it. I was speaking with my chapter lead today. He said something. They are deploying to production. He said, this is not just one person that is deploying to production. And it's the first time we are deploying to production. He said they were online till 3 a.m. on Saturday. So all these things they tend to happen so that you can see it yourself, and that's why they are paying you. That's why they are paying you big. Yes, of course, because when you look at it like, oh, Kubernetes, oh, Docker, it's no more than this. No, it's more. You troubleshoot, you get a lot of issues and all. I don't even know anything about DevOps before, but this awesome effort really has started great value. Yeah, nice to hear that. So that's just it anyway. I could easily just go straight but then now I didn't plan to use like 3 weeks or about 4 weeks now on Kubernetes, but it has happened. What do I do? It's not good for me as well. There are a lot of fun that I even want to go and have fun. I will not be able to have fun and say, oh, I have class today. Today now, we're not supposed to have the class today, but I have to have this class like, oh, we are spending too much time on Kubernetes. Let's quickly wrap up Kubernetes and do the next thing. Yeah, I'm really sorry about that, but I wish I could do something, about the back and forth. But this is one thing that interests me now. In fact, we've not even gotten to the most interesting part, which is what I do almost every day. But then it's good, just keep on following me. You're going to get to another interesting level. But let's continue. So now you can scale. Let me restart. Okay, let's say kubectl get ports. And DevOps. What?
You actually said it.
Oh, okay.
Zero.
Yeah, I changed
It was
okay. I was like, what? What's happening? Yeah, thank you. So I can scale it back up. And it's just a logic for actually restarting a pod. So when you look at it, get pods. So you see, so you have one running back. So that's scaling up and scaling down. I think there was this class. I also mentioned Lens. You can download Lens. With Lens, you have a nice view of dashboard. I was trying to use this dashboard on AWS, but it's giving me some issues. I'm not really enjoying myself, and it actually, this is the first time I'm actually working on AWS Kubernetes. So I'm just trying to figure out a lot of things, which is what really happened, which is really what really affected us. It's my first time working with AWS Kubernetes. So when you click here now, you can come here, resources. You can see the resources here. Look at the resources, ports, replica sets, deployment stateful sets. But here it's complaining like my current user or role does not have access to Kubernetes cluster, which is very, very annoying. I have to be honest, because I'm actually using a root user. So why is my root user not having access? So it's telling me I have to append a particular role. This is can't see nodes as a complete resources and receive AWS management. So it's telling me your current user does not have access. So it's telling me I have to append a particular permission, which is access Kubernetes API. So I'm going to do that anyway. So that's why I'm not able to see it on these resources. The reason I'm not doing it straightforward is because when I go to IAM role, I don't see how to actually append it to a root user. So that's another troubleshooting. So I've not been able to really check that out. Okay, so that's another. I'm just trying to show you, like, so if you want to check for resources, you can easily come here and be seeing all those resources, and you see everything here: daemon set, ports, jobs, cron jobs, all those things. But then let's just continue. So that's scaling up and scaling down. So now we are going to be using YAML to manage these resources. Let's use YAML. Okay, yeah, let's use YAML to manage these resources. So what is YAML? You know, I checked the meaning of YAML. There's different meaning, yet another markup language. So people, they call it, you know, a lot of things, a lot of name. YAML, okay, YAM-INT markup language. So if we say YAM-INT markup language, so if we say yet another markup language to create. So now, if you do HTML, you understand like HTML is not a programming language. Okay, HTML is hypertext markup language. Okay, so now the same thing as YAML. YAML is not a programming language. It's a programming language which actually it actually uses indentation for configuration. Okay, so in markup language now, maybe probably might need to set to yet another markup language. Yeah, yet another markup language. Yeah. So another person said YAML ain't a markup language. So you see when we actually look at it, this one is telling us it's YAML ain't markup language, but then when you look at it, YAML is to create configuration files with any programming language. Is fine for okay, another data. Okay, what I actually want to bring out is YAML actually use indentations for its configuration. Okay, so we have parents, we have child. It's like key value. Okay, so now let me quickly do a quick brush up of YAML. Let me do a quick brush up of YAML. This class is not covering YAML. If you want to understand more, YAML is pretty straightforward anyway. So if you want to understand more about YAML, you can just read about it. So this is the key and this is the value. It's just like you said, A equals to this, B equals to. So this is the key. So kind, deployment. YAML is a markup language which actually uses key value method. Okay. So now this is the key. These are the configuration for YAML. Okay, so if you want to do another thing too, there are other configuration. There are some other tools too that actually use YAML, but for Kubernetes, these are the configuration for Kubernetes. Okay, but let me quickly explain YAML as a whole. It actually works with indentations. Okay, if you take a look at the screen very well, you see these thin lines. Look at this line. Diagonally. Did I say diagonally? Vertically, rather. You can see these thin white lines, right? Hello, can you hear me?
Yes.
Okay. So now this thin white line actually means something. It actually means indentation. Look at this one. It's telling you no indentation. That's the first. Then the next one is one indentation. Then look at the third one here. That's the third indentation. Look at another one. That's the fourth indentation. So markup language actually works with indentations. Now look at it now. Look at this now. We are saying kind. What kind? We are doing deployment. Okay. Look at another key. Now, because it actually has different properties. So now look at it now. This is a key, metadata. So metadata, we actually under metadata, you have different properties. So now that's why it not see value in its front, because it has you are trying to specify different properties, name, labels. This is not Kubernetes. This is me just trying to explain markup. Are you getting it? So now I'm just trying to explain markup before I now explain it in Kubernetes. So try to understand the difference between Kubernetes and YAML. So you know, say, oh, Kubernetes is so difficult. That's what I'm trying to tell you. Like, this is not Kubernetes now. This is YAML. YAML is another thing on its own anyway. So now, look at this now. You can see this is the key, but this particular object actually has different properties. You know, it's expecting name, it's expecting labels. Look at it, label to still have two different properties under it, which is app and I don't know how to use whiteboard. Maybe that could affect me to explain better. How can I better illustrate this? How can I better illustrate this? Okay, now what this is just trying to tell you is, okay, labels and name and labels are properties of metadata. Why? Because it belongs, you know, this is the parent, it has indentation under. Are you getting it now? Now, when you look at this now, it's like we have one, we have one, this is one parent, this is another parent, this is another parent. Why? Because it does not have indentation. You can see. So kind is a parent, metadata is a parent, and spec is a parent. So under each parent now, so this one only has one, property, which is deployment. So, but this metadata actually has like two different offspring. You can see this is one indentation, this is another indentation. Okay, so labels again now have another offspring, which is app, because it's on another level, indent level, and you can look at it. It has app and tail. So you get it now. So the same thing for spec too. Look at this spec. Spec is a parent. Under spec, it has two different properties again, which is selector and template. Selector has another property which is called match label. Then match label has another property which is called app. Then this one has labels has another property which is called app and sire. So you may not really bother about this, but I'm just trying to explain how markup language actually works. It's a configuration language. You can use it to configure, which is what we are doing. Okay, so now let me now bring it to Kubernetes context now. Let me bring it to Kubernetes context. Okay. Oh, you're watching our video. That video is always fun. Okay, yeah. So now, the first thing we stated here is what kind. This kind is to specify what you are trying to do, what Kubernetes objects you are trying to do. So just like we specified here now, we have different objects, we have pod, we have deployment, you have service, you have daemon sets. So kind, that is what your kind is actually meant to do. If this is pod, you can just change this to pod. Okay, but now we are working with deployment, so that's why we have deployment. Okay, then metadata is, how do I explain, some extra information about the deployment. That's what the metadata is actually trying to do. So now the metadata is, we have name. What is the name? The name of it's always following this format. Are you getting it? So definitely you can just always copy, though there are some advanced level, like probably you start doing some life cycle, you have to implement some commands, some startup hooks. I will not be delving into that right now. Maybe later, that's an advanced, that's another level anyway. So I will not be delving deep into that, but at the barest minimum, let's just use this format. Okay, so this is the format. Now, the metadata, what is the name of the deployment? The deployment is called Nginx. Then labels is, okay, I omitted one particular line when we were here. Labels, yeah, I omitted this particular line. I said labels. So this L actually means label. It's a way for filtering a particular thing based on the label. So now, this label here is specifying like, okay, label for the deployment is called Nginx. So with the label now, you can have different properties, like, okay, which app does it belong to? Okay, Nginx, which tier, backend, okay? You can say which color, like you can just specify, it's just like a label. You can give it anything, just like you are labeling your book in your library. Are you getting it? So it can be anything, okay? So that's labels, but you must specify a name. This is mandatory. You must specify a name. The name can be anything. What do you want to call it? Now we are trying to deploy Nginx. That's why we name it Nginx. Then label, the app is Nginx, which tier, backend. Then the spec is actually used for specifying the pods. I told you deployment is for pod. So now, you're trying to configure the pod. That is what this spec is doing for you. Look at it now. You have spec. Let's actually. All right. So now, take a look at what is happening here. Take a look at what is happening here. Yeah, this is the more complete YAML file anyway. This is the more complete YAML file. Sorry, this is the more complete YAML file. So the first one here is the API version. Okay, that is the Kubernetes API version that we are communicating with. Okay, then the kind is deployment, then the metadata is the name. Then look at it here now, we have two levels of spec. You see, we have two levels of spec. The first spec here is describing the deployment itself. You know, I told you the deployment is actually used for managing your pod, right? Which you actually specify container. So this first spec here is actually talking about the deployment specifications, where you actually do the configuration for the deployment. So you have your selector, which you can use for searching. So look at this match label here. It says match label run is my Nginx. It can be, you know, it's just for you for filtering the deployment. So now, if you want to filter, like if you want to search for a deployment, you can easily run like with a filter key, which is run. Then the run, where's it here? Okay, look at this here now. So here we have kubectl get ports app equals to Kubernetes. So in that case, I can just say run equals to Nginx my Nginx. Okay, so that's match label. So now, the next one is replicas. How many replicas do you want to do? How many replicas? 2 replicas. Then you now have the template. Under the template, you have the metadata where you have your run label. Again, you have your run label again, which is my Nginx. It's literally doing the same thing as this. It's literally doing the same thing as this anyway. But it's like literally doing the same thing as this. But look at this now. The next level of specification now is this is for the pod. This is for the container. This is for the container. Okay. So for the container, you have your image. Look at the image. You're giving your container. You are giving the pod a name. You are giving the pod a name and then the image. But this second match label is actually referring to this pod. This first one is referring to the deployment itself. This second label here is actually trying to tell you the it's literally trying to tell you the match label for the pod itself. I'm going to explain why do we need this match label. Okay, so now why do you need this match label? This match label is actually useful, like so that instead of you, like I told you, like the IP of a pod used to change. So now service cannot, how can service actually know the ports that I want to expose? How? Are you getting it now? So instead of that, now instead of using name, you actually use selector, which is what you actually have, configured here. Your labels. Are you getting it? So now if you want to specify like service, which pod are you trying to expose? The pod you're trying to expose is what you actually have here. Okay, so you're just going to specify the name. Okay, look at it now. You have service, which selector are you trying to expose? Okay, I'm trying to expose run, a selector which the label is run, you know, and it's called my Nginx, which is what we have here. Are you getting it? So you can also have some filter and say, okay, subsets. You can have subsets, I call it backend, and then you're going to do the same thing to here. You add the subsets here, and you know, then you can also have different front end, back end, you know, blah blah blah. You can just keep on playing around. So that's the concept of this selector that you have here. Okay, then you know, this is container, just like you have in your Docker. What is the name? You know, so this is the name of the pod, the image. Then which port is it running on? So here we are telling you like, okay, it's already running on port 80. Okay, so do you understand this simple configuration? So this is a file on its own. Do you understand? So instead of running this single command now, this thing that we actually did here now, we can just replicate it and just change it here and say, okay, this image here, we are going to replicate, we are going to change it here. This is the image name here. Oh, this is the image that we are using here. So I'll just put the URL here. Then what is the name of the deployment? So the name of the deployment is this. So I'm going to change the name to here. Then the pod, it automatically picks the name of the pod. Okay, so I can just replicate it. I can just change it to here. And so it's like almost the same thing I'm doing here. That's what I'm now bringing into a file. Do you get that? Hello? Hello?
Hello, hello.
Yeah, am I communicating?
With you. Yes, sir.
All right. So this is also going to make more sense. You know, I said earlier, like myself, this is not how I do it anyway. This is just an interactive way of doing it. So instead of doing it interactively, you can just do the same thing inside a file. So that's what I'm going to be doing now. So now what I'm going to do is I'm going to copy this and create a file inside my terminal. Okay, I have to start. Okay, so ls, what do we have here? Okay, should I create, let me create a file, mpdir class. So seed into class. Okay, so now let me create a file. I'm going to call it deployment.yam file. Deployment.yaml. So you can do YML or YAML. So now I'm creating a file called deployment.yaml. Then I'm going to paste it. Okay, so now at times, if you don't do your indentation very well, it's going to complain. Now let's see if the configuration is okay. When you look at this API, this is API, this is the value, kind, deployment, metadata. The children must be on another level of indentation. Metadata is named, so there's indentation. So we have spec. So spec, since spec is staying alone, so we have selector. Match rebel is a child. We have run, so that's okay. Replica is under, okay. So to me, I think it's fine. Now look at this level now. Spec has another a child called container. So under container now, you actually know what they call array. So you have arrays of containers. That's why you have this hyphen. So when you are specifying arrays, you use this hyphen. That's why you have this hyphen here. So you have hyphen of properties here. So that's why you have you are talking about arrays, not properties. That's why you have hyphen here. So you have the first one, which is this. So the container now have the first array as property named image ports. So port 2 has different arrays. So you can have arrays of ports. You can have another container ports 8081, 8082. That's why you see this hyphen here. So when you want to deal with arrays, like arrays of objects, that's why you use this hyphen. Okay. So you can just read more on YAML anyway. You can read more on YAML, but for Kubernetes, at least if you want to know more about YAML, you can read more on YAML. But for Kubernetes, this is just sufficient. Okay. So then we have this, then I can save WQ. All right. So now, for you to deploy to Kubernetes, the command is kubectl. Let me put it here. For you to deploy to Kubernetes, you use kubectl create, then the name of the file. Okay, so the name of the file. Then you can also do kubectl apply. So now the question is, what's the difference between create and apply? I think with create, when you use create, you cannot actually update that particular object, but with apply, if you use apply, you can make a change on that object and apply it again and it's going to apply. So create can only create and you cannot update that object anymore. But when you use apply, you can always, I can again edit the file and then apply that particular object again. So let's see, this is the file. So let's deploy. So we are going to be using kubectl apply. because we might make some edits. kubectl apply. Okay, before I do kubectl apply, okay, yeah, it's fine, it's fine. Let me quickly show you something before I even apply this. kubectl get ports. You know, we actually get our ports. We deployed a port in namespace called DevOps. Do you know? And then we also have get ports. We also have service running in that same namespace too. We also have service running in that same namespace too. Okay, so look, when you look at this now, I can just easily say, okay, if I don't need this, if I don't need this thing again, I can just say kubectl delete namespace. This shortcut for namespace is called ns. I can delete the old DevOps namespace, and everything I actually installed in that namespace is gone and gone forever. So namespace DevOps deleted. So it's going to delete all these objects as well that I have deployed in that namespace. I think it's deleted. Let me just stop it anyway. So now let me try to get the service again and see what we have. No resource found in this namespace. Let me say get namespace. Let me see if the namespace is still existing. NS. So okay, so you see it already deleted. All right, so I just show you that. Now let me create another namespace. I'm going to create another namespace now. Let me create a new namespace. NS, I'm going to call it DevOps as well anyway. So now these are new deployments. I'm going to make it to the new. So now how do you configure a file to deploy to a namespace? There are two ways of doing that. I can actually put it inside this particular file. I put it inside this particular file here under the name. In this metadata under the name, I can specify, I can say namespace. DevOps. Okay, that is one way. Then I think another way that I can do is I should be able to specify while issuing the command. Let me try. So let's deploy to this particular namespace using the command kubectl apply. Then now once you run apply, I think I omitted that. Once you run apply, you have to put -f to specify the file name. So -f is to tell you like the file name, is to point to the file name, okay, to supply the file name, which is called deployment.yaml. Then n. Well, I don't really use this, but it's looking so weird. But let me try it anyway. I'm trying to deploy to DevOps, so let me see if it's going to work. So now I specify the file name as deployment. Then the namespace I want to deploy is DevOps. Let me see. Okay, so now it's telling us like deployment my nginx is actually deployed. So let me see kubectl get ports in this namespace called DevOps. All right, cool, man. So it actually worked. So you can see that now, right? And at the same time too, I can also delete. So, you know, I deployed to this a namespace using command line. Let me actually issue it inside the file. So before I do that, okay, since I even use apply anyway, so let me see. Let me just be safe anyway. Let me try to delete this. If I want to delete, I can just easily say kubectl delete. Yeah, delete. Then using file. I can say, okay, now see it's deleted. You know, I could easily say delete using the name, but now since I did not use name, I'm using file. So it's going to scan the file and say, okay, which kind of object, what is the name of the file and all. So that's why I use -f. Okay. So I don't know if you understand what I did there with my explanation. Do you understand what I did there? You know, before what we're doing is we specify kubectl delete. Okay, now we want to delete a deployment. We specify the name, we specify the namespace. But now I just said kubectl delete. Then I now said from file name. So now what this is actually saying is, okay, check the content of the file and delete objects related to the content of the file, which is kinda easy. So now let me try to deploy using configuration inside the file. So I can do that by just saying namespace here. I can specify the namespace. Can specify the namespace here and call it DevOps. And then say kubectl apply. Then I don't have to specify the namespace anymore. All right, created. Then let me try to get the source and see. All right, so you see, deployed into that same DevOps namespace. So there are two ways to it. Are we making sense?
Yeah, sure. You're making sense.
All right, good. So now, you know, the next one the one we did earlier was service, right? We actually deployed service by using expose. So now instead of using expose, we can actually create our service using a file as well, which is what we actually have here. Instead of using expose, what's this? Okay, get ports. Okay. You know, I explained about this label, how you can get ports filter by label. You know, that's what this command is just doing. Why this to give you more information about the ports. Okay, so when you look at it so far, you know, this is how I've been doing it. You see, I don't really have much information, but if I put wide, it's going to give me more information about the pod. You see, I was able to get nominated node, readiness, you know, blah, blah, blah. I have more information. But if I not put wide, it's just going to tell me the status, you know, the age. But yeah, I have extended information, even the pod IP, I have the pod IP and all. Okay, so that's what I have here. So then instead of using expose, you can also use your file to create your service. Let me do that and explain. So let me service, vi service dot YAML. Okay. And then, so now, what is the kind? Now we have API version v1. What is the kind service? Then the metadata. What is the name? The name is my Nginx. Then what is the label? We are giving it a label called my Nginx as well. So now, what ports? We are running it on port 80. Then protocol TCP. Then we are selector is for pointing to that particular port. The particular port, which is the selector we actually specify for this particular deployment, which is this. So that's why we have the selector here, okay, to select the particular port we are deploying this service for. Okay, so let's deploy. Now, you know, earlier on, we actually specify type as node ports. Okay. By default, if you not specify the type, I think it actually deploys as it deploys as cluster IP. Okay, so you can also specify the particular type, which is what I did here. You know, this is a type load balancer. But then let's deploy without specifying a type and see WQ. Then you do kubectl apply. Oh, I didn't put, sorry. Let me try to put the namespace anyway. Let me add the namespace as well. I'm deploying to DevOps namespace. DevOps. Oh, Sorry, my bad. No name, namespace. Are we tired? We'll try and wrap up in 7 minutes anyway. I thought we could be able to cover something that's even more interesting about Kubernetes that will make your life easy in Kubernetes. Yes, there's something we call Kubernetes Package Manager Helm chart. I plan to actually show us that as well, but we may not be able to do that today. But let's just quickly wrap this up and call it a day. So now I have kubectl. I have the service file. I have the service file. I've been able to explain the service file already. So then I can apply kubectl, apply. Then what is the file name? Service.yaml. Then I don't need to specify the namespace because I've configured it inside the file. Then it is already configured, so I can get it. Let me do kubectl get service. Shortcut for service is SVC. Okay, so kubectl get service. So I have it running, so you can see. So look, when you look at the type now, because I didn't specify, so you can see it sees it as cluster IP. Let me try to update it to node IP. Let me try to node port rather. Let me try to update it to node port. So now, if I want to update it now, so under this spec, I can say, I think it's type. I think it's also case sensitive, node port. So we capitalize N and capitalize P. I think so. Do I even get the right thing? Am I right? Node port. These things are fine. Okay, yeah. Let's just try it. I think that should be it. WQ. Oops. Node port. WQ. Then let's run kubectl apply. All right. So earlier it says created. So you see, because I run apply, it said configured. Now let me try to get the service and see what we have. All right, so you see it's updated to node port. Before we were having cluster IP, now we have node ports. So now it's actually mapped it to this port 3102. So I can go to my node and access it on 3102. I mean 3120. Just like we accessed it here, so I can access it on. Is this still running? This will no longer be running because I deleted it already. 3120. Oh, boom. We are what? We are up and running. Is it making sense?
Hello?
Yeah, sure.
Did we specify an IP, a static IP for it, that you could use it to check now?
Okay.
Because I think we use it in the other one that you deleted. The same IP.
I see my IP. Yeah, that was what I did. Node ports. The other one I deleted. This was what I did. Node ports.
Did we specify that particular IP, that 43.206 or something
You
there?
don't have to specify. How do you get the IP? The IP that we actually run it on is, we call it node port. What is node? The node is the node that is running inside your cluster. So once we are specifying a node port, it actually means you are trying to get the application on the node IP. So look at it, this is the node IP. So any application any service you deploy using node IP, you look at it now. The first one I access is using this. I can also access using this as well. 52.199.
Okay.
Yes, so I can also access every node. So I can access it on every node with that on that same port. So it means like it's accessible 31 120. It's accessible on every node running inside the cluster on this particular port. So you see 50.199.199.100. This
Okay, I've got that.
yes, so that's why you call it node port. Then we also have another one, load balancer. Okay, now let me quickly run this load balancer. Now, when you do kubectl get service, you see like external IP. Look at external IP, none, right? But the type is node port. Now, let me update it to load balancer so that you can see. You have this external IP. So it means like it doesn't care about which node. You can easily access it from the load balancer IP that was actually assigned to you. It automatically assigned the load balancer. Is it load balancer or load balancer IP? Yeah, load balancer. Okay, so WQ load balancer. Then I can apply. Since we are running in AWS, okay, configured. Let's get the service. Okay, so this is external IP. So
yes, I think this is what the endpoint.
Yeah, this is an endpoint. Yeah, so if I ping this now, it should resolve it to IP. So I'm expecting it to actually give me the IP. So if I ping this, it should be able to resolve to an IP anyway. Not known. So well, I can check. I can check on AWS anyway. I can check on AWS for the load balancer, and then I'll see the IP. Then I can now point. And even aside that, so I think if I describe, it can give me more details. I can run describe anyway. Load balancer. See, EC2. Load balancer. That's my EC2. Okay, so now this is load balancers. Let's see the load balancers we have. All right, so this is the load balancer that we have. Has created the load balancer. Look at the date. It was created today, 11:15. Then type. I'm trying to look for the IP for the load balancer.
I don't think it's specified for load balancer. You can use it like that to check our deployment. Can we put it on the web browser? Let's see if it's going to show it.
Yeah, it's going to show actually, but the reason why I care, the reason I cared about the load balancer IP is when you want to do your DNS configuration, it's expecting to see an IP. It's your load balancer IP that you are going to use to configure your domain name. That is, maybe you've already bought a domain name and then you want to point that domain name to a particular IP. Are you getting it? So that's why I care about the IP. Do you get me? Hello? Hello?
Hello. Yes, sir. I got you. Sir.
Yes. So that's why I'm really care. That's why I so much care about the IP, because if I really want to do the domain name, I will need the IP anyway. So where can I check for the IP? These are the instances. Yes, just tell you the instances connected to that load balancing, that is load balancing for listeners, monitoring, tags, description, name, status, subnet, port, security group, attributes. Okay. Is it like I have to I think another way I can go about that, is I can actually buy an external IP, elastic IP. I can buy an elastic IP. Okay. So if I buy an elastic IP, I will specify. Wow, who created this? Not IP. Oh, behind me. I have no idea about this. Anyway, when I delete the cluster, I think you should delete all this for me too, sure. So now I can buy elastic IP. Then once I buy the elastic IP, I can now attach the elastic IP to 6 minutes more. I can now attach the elastic IP in this configuration. In this service, there's a way I can specify IP. Okay, let me see how to specify external load balancer IP. Load balancer IP. There's this command, there's this configuration, how to specify static IP. Okay. Okay, so now this is it now. So load balancer IP, I can just say load balancer IP.
Okay.
That's for load balancer. You know, it's because I'm able to do that because I'm issuing it as a load balancer. Right? So try not to mix it up. You know, that's like I defined earlier. You have cluster IP, you have node ports, you have your load balancer. So now let me try to buy one external IP. Amazon pool of IPs. So I'm just telling you to just give me one IP and allocate. So it's going to give me one IP. So this is the IP that it actually generated for me. Okay. So now I can actually attach this IP here and save. To be honest, should I tell you a secret? Should I tell you something? My little secret. This is my first time I'm doing it. It's my first time I'm configuring something like this. So I'm just telling you, but I just have a picture of how this thing should work. Hopefully, let's just hope it's going to work. Anyway, I'm just telling you so that you can see how these things work. Have an understanding of this thing and you be at peace. Let me apply it and so you see. All right, configured. Let me get it and see. Oh, it thinks updates. Okay. Now, if that's the case, let's try to describe this and see what we have. kubectl, describe service. You have to specify what you're trying to describe. You're describing a service which is called my nginx. Which is called my nginx in namespace called DevOps. Describe. Okay, so let's see. All right, so is this the new IP I just allocated?
Yes.
5193. All right, 51. So why I'm expecting it to actually show, you know. So why is it not showing? It's supposed to show an IP for me. Yeah, that's what I'm expecting anyway. But since it didn't show it, so it's all fine. So this is the load balancer IP. Then I can easily access the application using that load balancer IP. Come on, please don't disappoint me, please. Please, I need it to work. Okay. Why is it not working? Oh. Oh, this is working. This is working. So why is this not working? Oil. No. It's a TCP. Load balancer IP. It's a load balancer. So why is it not accessible on the load balancer endpoint? Okay, wait. Error sync load balancer failed to ensure load balancer IP cannot be specified for. Okay, I never see this error. So error sync load balancer failed to ensure load balancer. Load balancer IP cannot be specified for AWS Elastic. Was load balancer. Okay, load balancer IP cannot be specified for AWS. Okay, so now I think this is the problem. Now I said load balance, so I have to remove the elastic. I think maybe it actually wants me to, it wants to automatically generate it for me. So let me edit. You can see the error here, right?
Yes, sir.
Yeah. So let me edit and remove the load balancer IP. Yeah. So let me apply again. Then I'll describe. Yeah. So I will describe. So I'll get the IP that is automatically assigned. So I think this is the IP that was actually generated.
That's the one you're looking for.
Yes. So let me see if it's accessible. Let me delete this. Release IP. Why is this not working? Show the balancer. Describe. Why is this not reaching again? Why? Please don't do like this, please.
Around or what? Are we done?
Okay, it's back. It's back now. I think there was a network issue.
So I'm back. So now that's just it. So I just tried to browse how to find my load balancer IP. So I just got some tutorials on process now, but let me not just waste our time. So just go through this process under load balancer, choose load balancer for the navigation, select the load balancer that you are finding IP address. So you could easily just do that, but I don't really want to go through that. I just want us to wrap it up. So now you could actually see also we've been able to configure a simple load balancer too. So let me see what next. So yeah, we can just talk about secrets, config maps, maybe next class, and mchats. Then that's it for Kubernetes. Okay. Hello, can you hear me?
Yes, I can hear you.
Yes. So any question before we just call it a day, please?
Yeah, okay. Just a quick one. The length, are we going to cover it?
No, the lens is pretty straightforward. Yeah, no problem. I'll try to see. Do I use it on Mac? I don't know if there's the Windows version. Let me see. It's pretty straightforward. Just install. I think it touch yeah. So when you have lens, you configure. You download Kubernetes on your Windows. Yeah. So you download Kubernetes on your Windows. Let me see if there's lens for Windows. Windows. Let's see. Office lens, capture information wide lens, lens to do. Is there lens for Windows? Okay, yeah, there is. So once you download the lens, then another thing you want to do is you want to download Kubernetes on your Windows, Okay, and then you configure it. You configure your kubectl to connect. Let me see. They have kubectl. Okay, yeah. Last time I told you I downloaded Kubernetes, but I didn't start it. So let's assume I have started it. Then it's automatically going to search for my kube config and connect itself. We can do it together anyway. Maybe at the end of next class. It's just like an IDE. Yes.
Okay.
Okay. Yeah, so this is a typical example. You can see all the things that I showed you. So instead of you just using command to be doing your troubleshooting, you can just be doing click, 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 click. But it's good you use command so that you get yourself familiarized with these things. But this lens actually makes your work easier and faster. My efficiency actually increased at about maybe about 300, 400, 500% when I started using lens, because in most of the time you are using issue command, but click, 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 click. That's the beauty of using IDE. So, any other question, please?
That'll be all from me. Thank you.
All right.
Yeah, thank you, Bolu.
All right.
Really appreciate it.
Welcome.
I want to point out that the YAML that you explained is kind of similar to JSON. So
Exactly.
if you are really, if we are, yeah. So if we are really familiar with JSON format very well, with the
JSON
Kiva
format.
loop here, I
Yes.
think all these Kiva loop here in YAML shouldn't be.
But I actually think
task
JSON can be a little bit complicated with all this what's it called?
Yeah, you're right.
Yama
For somebody that
yama
might
kind
not
of.
know what it's
Yeah.
all about.
Yeah, but it's
Yeah,
kind of
so
similar.
you have to remove all the what was it called, curly braces,
All the colleague
coupled with
bases.
some
Exactly.
other angular brackets. I think
Yama is a
it's
lot
going to be
easier.
very,
It's all the colleague bases.
yeah, exactly. Thank you very much. I'm enjoying this the more.
Yeah.
The more we dig
Actually
in, the
interesting.
more it's
That's what I'm
very clear.
saying. It's complicated at the beginning, but the more you go deeper, the more you find it interesting. And this Kubernetes is also very interesting. And next class we should talk about Kubernetes Package Manager, which is M. We should be talking about M charts. It's a Kubernetes Package Manager. It actually makes your Kubernetes even more interesting again, more easy and interesting. It makes your Kubernetes managing of resources very, very easy. You keep getting that, it keeps getting more interesting. You just have to keep doing your homework, practice, do it, learn, and all. So that if you not read it, if you not prepare, you don't understand the class, and then you get discouraged. But if you prepare ahead, you'll be more than happy because you're getting what is being taught. Okay?
Thank you so much.
Yeah, thank you very much.
All right. Have a good one. Bye-bye for now.
All right, good night.
Yeah, well.